Raw materials, particularly minerals and metals, are the basement of our daily life, society, diverse industries, national economies, and trades. They are an essential part of new technologies and cornerstones of all four industrial revolutions in humankind's history. In the heart of the first industrial revolution were coal and iron. The period is known for the introduction of new hot blast iron smelting and the widespread of steam engines. The steam power was mechanizing manual production, driving up industrialization and economic growth. The second industrial revolution introduces an era of electrically powered machinery and electric light, where copper and tungsten are gaining more attention. The third revolution is a revolution of semiconductors and electronics, with a wider range of non-ferrous metals and minerals utilized. Currently, we are observing the fourth industrial revolution of digitalizing every aspect of our lives, as well as the first steps in transitioning to renewable energy sources. That puts even higher pressure on mining metals and minerals of different kinds, as the hardware for the digital transition requires even more diverse list of raw materials. For example, it has been calculated that more than 60 different minerals contribute to modern computer chips and cell phones. On the example of wind farms, it is seen that rare earth elements are needed for the magnets, like niobium, dysprosium. Aluminum is required for the blades, and molybdenum and zinc as anti-corrosion agents, while lithium and cobalt are on the bond for the battery energy storage. It has been estimated that for the steel parts production of a 1 megawatt wind turbine, around 220 tons of coal is required. That means that most things surrounding us, starting from your smartphone and ending with the toilet paper, contain minerals. So where do all these metals and minerals come from? Here it is important to introduce a concept of a mineral, rock, ore, resources and reserves. Mineral is naturally occurring chemical elements or compounds in a distinct structure having characteristic physical properties. To form a certain mineral, elements should be presented in certain proportions at a given location for a certain time, required to arrange atoms in a structure of a mineral. Thus, physiochemical conditions such as temperature, pressure, pH, presence or absence of water and oxygen in the mineral formation environment play one of the major roles in a mineral genesis. There are 103 known elements which combine with each other to form more than 3,000 different minerals. By composition, minerals could be grouped into native elements, consists of one chemical element, such as, for example, gold or silver. Sulfides consist of various combinations of sulfur and metallic elements. An example could be pyrite, known as fool's gold, as it glitters in yellow. Oxides, which represent combinations of oxygen with other different elements, especially metallic elements. An example is magnetite, which is used for iron production. Halides are the minerals based on the elements of the seventh group of the periodic table. An example could be sodium chloride or just a regular table salt. Carbonates are the ones with the carbonate radical in a structure. An example is a calcite. The next group are phosphates or minerals with a phosphate radical, like apatite, which is used for fertilizer production. Sulfates has a sulfate radical. An example is gypsum. And the last but not least, silicates, one of the most abundant group, which contains silicon and oxygen in a structure, and an example would be quartz. Economic minerals are the ones that have distinct applications in different spheres of world economy, for example, construction, manufacturing, agriculture, etc. Economic minerals, according to their application, are divided into energy minerals like coal, oil, uranium, metallic minerals like for example chalcopyrite, used for copper production, or hematite, which is used for iron production. Construction minerals like quartz sand, mineral clay or gravel, and industrial minerals, or also known as non-metallic minerals used for a wide range of industrial and agricultural purposes. An example is potassium salt on the fertilizers market. When one or more distinct mineral or minerals create assemblages, it is called a rock. In simple words, rocks are like puzzles or Lego constructions made out of mineral grains. As an example, such minerals as feldspars, quartz and micas, when combined, form a rock called granite. When economic minerals occur in a sufficient quantity and their recovery and extraction is feasible from the ground under given conditions, they are called ores. Another important term in this topic is mineral resource. It is a concentration or occurrence of solid material of economic interest in the earth's crust in such form, grade, quality and quantity that there are reasonable prospects for eventual economic extraction. In simple words, we see a potential to investigate more certain areas. Mineral reserve are also known as ore reserves, is already economically mineable part of measured or indicated mineral resource. To understand better the resources and reserves, imagine an iceberg. The visible part of an iceberg is a mineral reserve, as it is well known, measured and ready to be extracted, while an iceberg with poorly known underwater parts embody mineral resources. We know they are there, but we don't know how much exactly, and if it is economic to exploit these harder to access iceberg parts. On the scheme you see that by increasing geological knowledge, which is usually achieved by drilling more drill holes, we increase the level of confidence and move the resources from the most unknown, inferred, to indicated and measured. Next, in order to move the resources to reserves, other dimensions should be considered, such as economic, environmental, mining, metallurgical, governmental, and any other which could influence the ability to actually extract the ore from the ground. Because ores are irregularly distributed in the ground, they are often extracted with so-called host or waste rocks. These host rocks do not contain economic minerals or have them in quantities below economic interest. The proportion of waste rocks extracted together with ore is known as dilution. Because of that, extracted from the ground mixture of valuable and waste rocks and minerals is delivered to mineral processing facilities. The idea of mineral processing is to extract from the mineral grain mixture only valuable economic minerals. As a result of mineral processing, at least two streams are produced. Ideally, it is a concentrate, which contains economic minerals, and tailings, or a waste stream, which has no economic minerals or have them in small quantities after the separation. To separate this mixture of different minerals, we refer to the definition of a mineral, which tells us that minerals have different chemical and physical properties. So, mineral processing concentrating methods uses these properties for the separation of minerals. The main methods are gravity separation, which uses the fact that minerals have different densities, magnetic separation, or a method based on the fact that minerals have different magnetic susceptibilities, or in simple terms, some of the minerals could be pulled by a magnet, electrostatic separation, which uses electrical properties of minerals like conductivity, and flotation, which utilizes physical chemical differences of mineral surfaces. The last method is more complicated than the previous three, and the most widely used one, so this series of lectures will focus on it.